So we're going to talk about matrix notation and Gaussian elimination. So what is a matrix? Matrix is an array of numbers with m horizontal rows and n vertical columns. Okay, so the numbers in the array, those are called elements. So if you are asked to find an element in the matrix, that's one of the numbers in the matrix. So if this is the case, you have m rows and n columns. They call this an m by n order. So if you're asked to find the order of the matrix, it's how many rows times how many columns. So rows by column. Okay. All right, so if I have this matrix 1, 2, 3, 4, 5, 6, 7, 8. Okay, how many rows do I have here? There are 1, 2. There are 2 rows. Okay, how many columns do I have? Well, I've got 1, 2, 3, 4. So let me do that here. Let me do a different color. 1, 2, 3, 4. So there are 4 columns. When I think of columns, I kind of think of like, on a building. So with a building, maybe you've got some columns holding up the porch or whatever. Okay, so these vertical pillar type things, those I think of columns. So that's kind of how I remember which one the columns are and which one are the rows. Okay, so the order of A is what? Well, it's a 2 by 4. It's rows by columns. It's a 2 by 4 matrix. So you might be asked to find the type. Now, these elements are named by lowercase of whatever the letter is that represents it. And the first part is the row, and the next part is what column. Okay? So if I say A11, so A11 means first row, first column. So first row, first column. So that would be 1. Okay? If I said A12, that's the first row, second column. Second column, so that would be equal to 2. A13, that's the first row, third column. If I said like A24, this is row 2, right? Row 2, and then column 4. So what number is that? That's 8. So hopefully that helps you there in figuring out what those pieces are. Okay? So I didn't go in any particular order, but just in general, Aij refers to the element, which is your number, in the ith row in jth column. Okay? So that's to help you out with that stuff. All right. Now, you're going to be asked in some of your questions to write the augmented matrix. And when you know what that is, it's no big deal. But if you don't know what it is, it's like, what? Augmented? What's that mean? Right? The augmented matrix corresponding to the following system of equations. Okay, so what? So here's my system of equations. 2x plus y equals -4, and -5x plus 3y equals 8. Now, when you're going to do an augmented matrix, the first thing you need to do is make sure your variables line up, your constants line up, and your equal sign line up. So my x's are together in a column, my y's are together in the column, my equals are together in a column, and my numbers, my constants are together. Once I'm set to that, now all I have to do is look at the coefficients. So number one, make sure variables and constants line up. Okay. Number two, only need to keep track of coefficients. All right, so what are my coefficients here? I have a 2. What's the coefficient here? It's understood to be a 1. What's the coefficient? What's the number here? The constant is a -4. And then down here, I have a -5, and then 3, and then 8. And I close it off. All right? And that, my friends, is the augmented matrix. Now, some texts, they put a little dash line through here, and you can do that if you want. You don't have to. It's not required. But if you see that dash line, that's just kind of its way of being like, oh, there might be an equal sign here. Okay, so taking that into account. All right. So what I want to do is I want to try one where it's not quite as easy. So here, it's not terrible, but it's not quite as easy. 2x minus y over 2 equals 3 minus z. Z minus x plus 5y equals 12. And then x plus 3y minus 2 equals 2z. Okay? So what do we need to do here? We need to simplify. So I'm just going to go row by row. So I want it to be x, y, z, and my number. Okay? So divide by 2 for these parts, that gets me 1x. And then that gets me what? Minus 3y equals 3 minus z. So what do I need to do? I need to add z to both sides. Now I think I'm good. I got x, 1x, minus 3y plus z equals 3. So x minus 3y plus z equals 3. That's my first equation. Good to go. Next one. Okay, my next one, this one here. I'm going to move the x around. I'm going to make it negative. I'm going to put the negative x first, and then I'm going to have my 5y, and then I'm going to have my z, and that equals 12. That one was pretty easy to do. This last one here, what do I need to do? I have x plus 3y minus 2 equals 2z. Well, I need to move the 2z over, so I'm going to subtract 2z from both sides. So I get x plus 3y minus 2z minus 2 equal to 0. Add 2 to both sides, and I think I got it. So I have x plus 3y minus 2z equals 2. So now now that I have my x's lined up, my y's lined up, my z's, and my constants, I can do the augmented matrix. And the augmented matrix is what? It's 1 minus 3, 1. Where are the 1's coming from? Coefficients in front. No number in front. It's understood to be a 1. -1, 5, 1. See, look, that's a -1 in front right there, right? And that's a 1 there. And then 12. Then I have a 1, 3, a -2, and a 2. Boom. Just like that. And so now what do I do? Because that's a big old mess. If I wanted to solve this, by the way, what is this matrix? What's the order of this matrix? The order is row by column, right? So row by column, how many rows are there? There's 3 rows. How many columns? There's 4 columns. 1, 2, 3, 4, right? 4 columns. So it's a 3 by 4 augmented matrix. Okay. Now, if I was going to solve this using my calculator, I'm going to give you the step-by-step, every button you need to press in your TI-84. Hit the second matrix, okay? Then you're going to hit Edit, and you're going to select the first one, A. After you do that, you're going to enter the size. Enter the size. What's the size? That's the order. It's a 3 by 4. Then you enter the elements. Okay, the numbers, right? Enter the numbers in. All the numbers. All 12 of them. Okay. After you do that, hit second mode to quit. Okay, because you want to get out of the screen. Then you're going to hit second matrix, and then you're going to hit math, and then you're going to hit the RREF button, and then you're going to hit second matrix and select the augmented matrix. Okay, you should have put it in A, right? So if you put it in A, select that one, and then hit enter. And what you should see when you do this, you should see RREF on your screen, and then you can put the A in, and then close your parentheses, and then you hit enter, and it does the work for you. And so what are you doing here? You're doing, RREF is called reduced row echelon form. Okay, and this thing takes your augmented matrix. So my augmented matrix here, right? It takes that matrix and it spits out a new matrix. Okay, it spits out a new matrix. It says 1, 0, 0, and then like 5.056. Then 0, 1, 0, 2.389, 0, 0, 1, 5.111. Okay, that's nasty. Those numbers are nasty. So what you're going to do, you're going to hit math, and then you're going to hit frac. And when you do that, that's going to make it turn into something really pretty. Okay, well, pretty in that you don't have any more decimals. Okay, so that's going to give you 91 over 18. 43 over 18, 46 over 9. And if you didn't get those numbers, then you need to retype it in, because chances are you probably just entered in one of your numbers wrong in your matrix. Okay? Now, how do you read the solution? Okay? So remember, the first column, those are my x's. The second column, those are my y's. The third column are my z's, and the last are my numbers. So I'm going to re-equationize this first row here. So this is going to be what? 1x plus 0y plus 0z equals 91 over 18. This reduces to what? X equals 91 over 18. Wow. What about this next one? This is 0x plus 1y plus 0z equals 43 over 18. Re-equationize, this is y equals 43 over 18. And then the last one is 0x plus 0y plus 1z, right? So I'm just taking the z and putting it with everything in that column. Taking this y, putting it with everything in that column. Putting the z, or that x, with everything in that column. And then those are just my numbers, right? And this is equal to 46 over 9, which tells me z equals 46 over 9. So what? Really, if I just read this and I have it in order like I do here, then my answers are X, Y, Z. Okay? X, Y, Z. It's spelled out right there for you. So what does my solution look like? The solution is the ordered triple 91 over 18, comma 43 over 18, comma 46 over 9. That's my X, Y, Z coordinate. Okay? Pretty cool stuff. So there's three types of systems of equations that we're going to deal with. Okay? So three types of systems of equations. So the first type, there is one unique solution. One unique solution. Okay, one unique solution. So previous, if I did a RREF and I run through it and I get like 103 and 01 negative 2, what does this tell me? X, Y, and my number. So that tells me X equals 3 and Y equals negative 2. Okay? It's a single ordered pair, right? So it's like when I have a situation where one line crosses another line. Okay? Now, I didn't do this right, but maybe it's like down here. Okay? So at 3 comma negative 2. So I have two lines. When they cross at a single point. That would be a single ordered pair is the solution. Okay? So if you have this scenario where these first pieces over here have ones on the diagonal and zeros everywhere else, and then you got your numbers on the other side, then you're good to go. Now, a situation where you might have no solution or the empty set. Okay, what is this? This would be like you do an RREF, and then you get like 1005, 0102, 0003. Why is this an empty set and no solution? This says I got an X, Y, Z and my number, right? This says X equals 5, Y equals 2, and then, this last row here, this is all zeros. So that says 0 is equal to 3. Now, in what universe is 0 equal to 3? That's a contradiction. Okay, you can't have 0 equal to 3 here. So what does that tell me? There's no solution. So if you run your RREF and you get, your last row gives you something like this, where you have a bunch of zeros and then equal to some number here that's not 0, then you know there's no solution here. So that's two of the three types. The last type, the most interesting one, is when you have infinitely many solutions. So with this red one here with no solution, this would be like an example where I have two parallel lines. Never do they cross. Okay, they don't ever cross. They never intersect, so there's no solution. That would be in a two-plane space. Okay, so infinitely many solutions. This would be like if I RREF'd and I get 1015, 01 minus 3, 2, and then 0000. If you get something where you have a row where they're all zeros, does this contradict anything? Well, let's see, X, Y, Z. Okay, and then your number. So I have X, 1X plus 1Z equals 5. What else do I have? I have on this row here, I've got Y plus, that's a minus 3Z equals 2. And then this last row says 0 equals 0. Is this true? Yeah, that's true. So when I have 0 equals 0, that's telling me right here I've got infinitely many solutions going on. So this statement here is always true no matter what value I plug in. Now, how do we write the solution set? Okay, how do you write the solution set? Because it's not just a single point like this one is just a single point, 3 comma negative 2. It's not no solution. We can't just put the empty set, right? So how do we do it when there's infinitely many? Well, I'll look at this here and I say, okay, what do I have that's in both equations? Well, I got a z in both of them, all right? So I want a solution set of x, y, and z, right? So how can I get x by itself? I take this equation and I solve for x. X plus z equals 5, so I minus z. And I get x equals 5 minus z. So the first part is 5 minus z. Okay, what about my y? How do I get y by itself? Okay, solve for y. So y is minus 3z equals 2. So I'm going to add 3z. So I get y equals 3z plus 2. So I get 3z plus 2. Now what about z? What do I do for z? There is no z there because it was 0, 0, right? So what do? I just put z right here. So everything now is all in terms of one variable. Okay? So my answer here is 5 minus z, comma, 2 plus 3z, comma, z, as long as z is some real number. So z is a real number, okay? And this is my solution set. All right? That's an ordered triple written in terms of z. Okay, guys, so you have seen it all now. So like in a 2D space, what would this look like? This would be like if I have a line, and then guess what? There's a line on top of another line. There are infinitely many solutions to that equation. All you got to do is just pick any dot you want on the line, and it's on both of them there. Okay, so that would be an example in 2 space. All right, so 3 different scenarios going on. You can either have one unique solution, no solution, or infinitely many solutions. Okay, guys, it's been fun.